Hello everyone, welcome to all of you. In the last lecture we discussed about entropy. What is entropy and how it is useful in the thermodynamics. And first of all we discuss a Kelvin-Planck statement, because entropy comes from the second law of thermodynamics. And we discuss the Kelvin-Planck statement and further discuss Clausius statement, and then we discuss about a reversible cycle and a reversible cycle based engine, that is the Carnot engine. And we also say that reversible cycle efficiency depend upon the temperature limit. In any reversible engine, that cycle is depend on the higher temperature and the lower temperature only. Now we further move on the topics, that is dq by t. dq by t is this is a reversible dq by t is equal to ds. This is also discussed. This term is used by the Clausius, and Clausius state that ds, that is the entropy is the property of the system, and it depends on the point, any point, that is any process 1 to 2, and this path is reversible, that is the R1, and another path is followed by R2. Then the entropy change in 1 to 2 in this path, and 1 to 2 in this path, that is R2. Then we get the same value, that is ds. ds is the property of the system, and it depends only on the point, not on the path. And we also discuss Clausius inequality theorem. Clausius inequality theorem. This theorem say that cyclic integral of dq by t is always less than or equal to 0. This is discussed in the last lecture, and our today lecture is starting from this topic, Clausius inequality. The Clausius inequality say that every cycle, the cyclic integral of dq by t is less than or equal to 0. That means in any cycle given, that is any cycle 1 to 2, 2 to 3, and 3 to 4, and 4 to 1. This is the TS diagram. Suppose that this is a TS diagram, and we calculate the value of dq by t for this cycle. Then if we get the value dq by t in all the cycle is less than 0, then we can say that this cycle is irreversible. If we get the value of dq by t is equal to 0, then this cycle is reversible. There is two possibility, either cycle is irreversible or reversible. Third thing is not possible, that is dq by t cyclic integral is greater than 0. This is not possible. Not possible. If a cycle is present, then cycle is reversible or irreversible. Third thing is not possible. And now we see that entropy change in irreversible process. So what is entropy change in irreversible process? Clausius said that any reversible process, for example 1 to 2, this is a reversible process, then ds is equal to dq by t in a reversible process. But there is an irreversible process, for example 1 to 2, this is a irreversible process. So what is the value of ds? What is the value of ds? We find it. What is the value of ds? If here dq is a heat transfer in an irreversible manner, and here dq is possible heat transfer dq in a reversible manner, then ds is equal to dq by dqr upon t. This is the entropy change in reversible process, but ds is not equal to dq by t. This dq is this. It is not possible. So what is the value of dq by t in irreversible process? Now we can see here and prove that what is the value of dq by t in the irreversible process. For calculating this, we take a process. Now calculating the dq by t in irreversible process. We take a cycle. You can say that you can see that here a cycle, for example 1 to 2. There is a process 1 to 2. This is the reversible process, and path followed by A. The path A is a reversible process, and second 2 to 1 is also a reversible path. This path name as B. You can see here 1A 2B1 become a reversible cycle. 1A 2B1 become a reversible cycle. This is a reversible cycle. 1A 2B1. This is the reversible cycle. How? 1A 2. We consider reversible path. This is the reversible, and 2B1 also reversible. Then both process are reversible, then cycle become a reversible cycle. And we know that Clausius inequality from Clausius inequality for reversible cycle dq, cyclic integral dq by t is equal to 0. This is the proof in part 2 entropy lecture. You can see that video which link is in the description box. You can see this proof. Clausius inequality say that cyclic integral of dq by t is equal to 0. This is valid for reversible cycle. And we see here 1A 2B1 is a reversible cycle, and we can separate this term for this cycle. One cycle path A 1 to 2 dq by t plus path B 2 to 1 dq by t is equal to 0. dq by t, from here we can write 1 to 2 dq by t path A, dq by t path B 2 to 1 is equal to 0 from this equation. Now we can also write 1 to 2a dq by t is equal to minus b 2 to 1 dq by t. This is the equation number 1. Equation number 1. Now we discuss entropy change in irreversible process. We can assume that a process 2 to 1 and process 2 to 1 is irreversible and path follow by C. Then we get another cycle, that is 1a2 c1. This cycle is irreversible. You see here 1a2 c1, this is the irreversible cycle, and Clausius said that in equality law dq, cyclic integral dq by t is less than 0. This is valid only for irreversible cycle. We can divided this term in the cycle 1a2 c1. There is no space, so I rough this term. For irreversible cycle 1a2 c1, here cyclic integral dq by t is less than 0, and 1a2 c1 we can write dq by t here path follow by a 1 to 2 plus path follow by c 1 2 to 1 dq by t is less than 0. We can see here dq by t 1 to 2 is equal to minus 2 to 1 path b dq by t. We replace the value of this term minus, this is the equation 2. From equation 1 and 2 we can write dq by t path b 2 to 1 plus c 2 to 1 dq by t less than 0, and also we can write 2 to 1 c dq by t less than, this term is going on this side, dq by t be 2 to 1. We see here path C is irreversible, and our topic is also entropy change in irreversible process. So what is the value of entropy change in the process 2 to 1 followed by the path C? Now we see here path C 2 to 1 dq by t is less than path B dq by t 2 to 1. 2 to 1 path B is reversible path and 2 to 1 path C is irreversible path. Now our study is that entropy change in irreversible process. Irreversible process is that 2C1, 2B1 is reversible and 2C1 is irreversible. Here we see that C2 to dq by t is less than dq by t. This is the reversible term. This is reversible. You see here 2 to 1, this path B is reversible, and for reversible dq by t is written in the form of entropy change, that is the ds. Then we can write here 2 to 1 c dq by t is less than ds. and ds ds is the property of system. That means ds 1 to 2 path c is equal to c 1 to 2 b ds. ds is the property of system. Either follow path b s2 minus s1 is equal to either path follow by c s2 minus s1. So we can write here c2 to 1 dq by t is less than ds. That means for any process ds is always greater than dq by t, and this dq is here dq. This dq is a irreversible heat transfer. That means ds is always greater than dq. dq is a irreversible heat transfer. So our result is that the entropy change in irreversible process is always greater than dq by t. But for reversible ds is equal to dq by t, and for irreversible ds is always greater than the dq by t. And we can write in generalized form, ds is greater than or equal to dq by t. This is the generalized form. For reversible process, ds is equal to dq by t, and irreversible process ds is always greater than dq by t. If any calculation ds is less than dq by t, then that process is not possible. Process is only two type. Process, it is a reversible or irreversible. Third is not possible. This is the not possible. Now we can see here ds is greater than or equal to dq by t. This is the valid for the irreversible process as well as reversible process. Now we are going to discuss about entropy principle. What is the entropy principle? How entropy is increasing of the universe. This principle said that the entropy of universe is always increase. How it is possible? We see here. We get in the last topic ds is greater than or equal to dq by t. This is, suppose a system we take isolated system. So what is the isolated system? Isolated system is that their mass is fixed and energy is also fixed. Neither mass transfer to the system nor energy transfer to the system. That system is called isolated system. That means here in del E is equal to 0. That is energy, and del mass is also equal to 0. That means mass is also constant and energy is also constant in the isolated system. And now we put here ds entropy change. That is the entropy change for infinitely small elemental process, that is dq by t. This is the reversible. If there is a irreversible, then we can get ds is greater than dq by t. But our process is here reversible or irreversible. But if we take the isolated system, then dq is the zero. Why dq is the zero? Heat transfer is a form of energy, so energy is always constant of the isolated system. Then ds isolated system is dq is 0. Then here we take the value 0 and we get the entropy change of isolated system is always equal to 0 or greater than 0. This is known as entropy principle. Entropy principle says that the isolated system entropy always increases, never decrease the entropy of isolated system. And isolated system, you can imagine what is the isolated system, what is the example of isolated system. The best example of the isolated system is the universe. That is if this is the system and here surrounding, and we take both system and surrounding, then we get the universe. What is the universe? Universe comprises system and surrounding. That means if we take the universe as a system, then it become isolated system. So we called the isolated system is here, the ds is universe. ds of universe always greater than or equal to 0. That's why called entropy of universe is always increases, because isolated system is the universe. Universe is assumed that the isolated system, and entropy of universe is also increasing. We can also write this ds universe is equal to ds system plus ds surrounding. That means entropy change of universe is equal to entropy change of the system, and entropy change of the surrounding is always greater than or equal to 0. If process follow reversible process, then the entropy of the universe is equal to 0, and if process is followed by irreversible, then the entropy change of universe is always positive. So we can say here the entropy of the universe always increasing, because this value never getting negative, always greater than 0. So we called the entropy of universe always increasing. We discuss here entropy principle, and the application of entropy principle is discussed in an upcoming lecture, and we also discuss how to solve the entropy numerical in upcoming lecture. Thank you.